So today is the last class. Hope you enjoyed the last problem set as much as I enjoyed writing it for you. In the last lecture, we talked about competition policy, right? And the goal in competition policy was to try to prevent firms from engaging in harmful collusion, either by merging or by colluding with each other illegally, right? But I think it always seems a little bit funny to people when they first learn about competition policy, because they think in many cases we want people to cooperate. We don't want them to not cooperate. We want to stop them from cooperating, right? And I think that intuition comes out of a sort of different area, which is when there are public projects, then it's very important that people cooperate and sacrifice their own self-interest in order to help facilitate the public project. And that's what we're going to be talking about today. Public projects are ones that bring benefits or costs that are spread out over a large number of individuals. And therefore, individual initiative on a voluntary basis is typically going to be insufficient to achieve an efficient level of that good. So to emphasize the links between this and what we've been studying with oligopoly, we're going to begin by talking about the collaboration problem of Cournot, which was his other model other than his model of competition. And that, rather than giving sort of the optimistic message that when there are a large number of firms we get towards perfect competition, is going to give a very pessimistic message that as the number of firms gets large, things are going to get worse and worse. And then I'm going to relate that problem of collaboration to the problem of public goods, define public goods and bads more explicitly, talk about private solution to public goods problems and why they don't work, and therefore why coercion is necessary for dealing with public goods, as well as public bads, such as the assembly of complementary property and eminent domain. And then I'm just going to do a brief wrap-up of the course. Okay. So Cournot was a pretty smart guy. He, in 1838, wrote down the first model of monopoly, the first model of competition, and the first model of public goods, all in one little book. And his model of public goods might not initially look like a model of public goods, but it really is in the end, as we'll see. So imagine a case when there are n different firms, and rather than producing goods that are perfectly substitutable for one another, imagine that they produce goods that are perfectly complementary with one another, right? So what does that mean? That means that consumers need to get all of the goods in order to obtain any value. And therefore, the amount that the consumers are going to purchase depends on the sum of the prices of the goods, rather than the price of the good depending on the sum of the quantities, as before, right? And so there will be a demand function Q, which is a function of the sum of the prices. For simplicity, let's again assume constant marginal cost. Each firm is going to make a profit, which is their markup, price minus cost, multiplied by the quantity, which depends only on the sum of the prices. Another way of putting that is that their profits are their markup times the quantity, which depends on the sum of all the markups, capital M, plus the sum of all the costs, capital C, not minus. Sorry about that. Okay. So, Agnès, what is going to be the optimal pricing by the firm? What would be the equation for their optimal price to charge?
So, optimal in terms of
maximizing profits.
We have to pay some marginal revenue for FC.
Mm-hmm. So here's their profit, right?
Yes. So we have to derive the marginal revenue. Derive it.
Yeah. So I've written this in terms of price, so it's going to be a little bit harder to find the marginal revenue. You might want to just take the derivative with respect to price, but if you want to turn it into marginal revenue, you could do that too. Imagine each firm takes all the other firms' prices as given, right? And then chooses its price optimally. You could do it on the board if you prefer. No.
So C is a firm profit.
Uh-huh. And they can choose their price PI.
Okay.
What do we do to maximize a function?
Just do it here.
Okay, so what's the derivative of this with respect to PI? Remember that capital P is the sum of all the prices of all the firms, and that the firm is taking the other firm's prices as given.
So it's Q prime.
Yeah?
Times PY minus CI.
Yeah?
Equals 0.
Yeah?
And so PI times CI.
Sorry? PI minus CI times Q prime plus what? Because you have to take the derivative of PI, right? There's two terms here, right? There's Q, which depends on P, and there's also PI, which depends on PI, right? So both of these two terms are a function of PI, right? This one has PI plus all the other prices. This one just has PI. So you take the derivative of the first term times the second, so you get Q plus PI minus CI times Q prime, right? And then you're going to set that equal to 0, and you want to solve for the price. So what's that going to be? Okay, so you get Q plus Q prime times the markup of the individual firm is equal to 0, right? Dividing through, you get the markup is equal to negative of Q over Q prime, right? Now, this is for the markup of one firm, right? But all of them are symmetric. So again, each individual firm's markup is the total markup divided by n. And so we get that the total markup is equal to negative n times Q over Q prime, right? Okay. Now, notice that this is exactly the opposite of competition, right? Because remember that P prime is Q over Q prime. Sorry, P prime is 1 over Q prime, right? And so this is negative of this. Okay, so the total markup under competition, right, is set equal to P prime times Q divided by n, right? Which would be Q over Q prime, sorry, negative of P prime times Q divided by n. That would be the same as Q over Q prime divided by n. But here, instead of being divided by n, it's getting multiplied by n, right? So as the number of firms gets larger, the markup is getting larger at the same rate that it was getting smaller under competition, right? This is what's called the double or multi-marginalization problem. The more firms, the worse things are, right? The higher the markup is getting. So let's consider a simple example of this. Imagine that Q is equal to 1 minus P, total price P, and the costs were 0, right? What is the value of negative Q over Q prime King Solomon?
Well, you just have 1 or negative 1 minus p over negative 1, so p minus 1.
You didn't cancel both the negatives, but yeah, so it's just 1 minus p,
Okay,
right?
yeah.
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 Yep. Okay. So then, Jackson, what's the equilibrium price given the equation that we had derived here?
Okay, so we have markup is equal to, what is that, negative n over q over q prime, which is equal to 1 minus p. So we have
Yeah.
markup equals n 1 minus p,
Yeah.
or n minus n.
And the markup here is just the price because everyone's cost is 0, right?
So you have price equals n minus np.
Yeah. So we want to solve that out for p.
So that's just 1 over 1 minus p.
Yeah. So, but you want to solve for p, right?
Oh, sorry.
So you want to solve that. So that's n is equal to n minus np, and you want to solve that for p. P is equal to n over n plus 1, right? Right?
Yeah.
Because you move the np to that side, you factor out the 1 plus n, and you divide through, and you get n over n plus 1, right? Okay. So, Agnès, what is quantity then? If price is n over n plus 1, what is quantity?
So it's 1 minus 1 n over n plus 1.
Right, and so what's that?
It's 1 over n plus 1.
Yes, exactly. Okay, so Clemence, what's happening as the number of firms are getting large? What's happening to price and quantity?
The quantity is diminishing.
Yep, and in particular, where is it going?
Sorry?
What is it going to asymptote to?
0.
0, right? And what happens to the price?
The price is going up
To,
to 1.
yeah, which is the point at which nobody is willing to purchase above that point, right? It's called the choke price. And this is exactly the opposite of what happened under Cournot competition, right? Under Cournot competition, the quantity went to the full quantity, and the price went down to 0, right? The fundamental problem here is, remember that under competition, firms didn't take into account the way in which they're increasing their quantity or lowering their price hurt other firms. Here, firms don't take into account the way in which they're raising their price hurts other firms. Why does it hurt other firms when they raise their price? The products are complementary. If I raise the price on my product, that makes it more expensive to buy your product, right? And in fact, the formulas here are essentially exactly the same as with linear Cournot competition, except that the role of price and quantity were interchanged, right? That's actually more generally the case, right? In fact, these problems are equivalent or dual to one another. In one case, price depends on the sum of the quantities. In the other case, quantity depends on the sum of the prices. And so they're literally the exact same situation except reverse. So let's go through that. So under Cournot